Hey everybody, today we're going to start a new topic and it's called exponential functions. So take a second, think about why this topic is called exponential functions. Okay, cool, exactly. It's called exponential functions because of course we have exponents. We have an exponent here, we have an exponent here. Apart from the fact that they're exponents though, do you notice something special about these exponents? Well, if you are thinking that yes, in both cases the exponents are x, you are correct. So in exponential functions, the variable, the exponent must be a variable. So that's pretty important. Take a note of that. An exponential function has a variable in the exponent. So now I'm guessing you're wondering, what is all this other stuff? What is this? What is this c? Hold on a second, let me change my pen. What is the c? What is the k? What is the y? What is the f of x? All of that stuff you're probably wondering. And we'll get there. Don't worry about it too much. But what is important for now is that you know that an exponential function can just have numbers where you have the c and where you have the a and also where you have the k. They're just numbers. They're letters that represent numbers. As long as the exponent itself stays a variable, then it's an exponential function. Okay. So now we're going to look at evaluating exponential functions. And what I mean by evaluating exponential functions is exactly what it sounds like. Finding the value of a function that's exponential. So let's look at the first example, and that is f of x equals 2 raised to the x power minus 3. Now, right now, we don't have a value for x, right? But let's say I wanted to know, let's say I gave x a value. Let's say I told you that x is actually, instead of just being x, it is 1. And I ask you for what is f of 1. Sorry about the bad handwriting. I'm using a mouse, and it looks really bad. But okay, so we want to know what f of 1 is. That means in our function, everywhere that x is, I'm going to now put 1. So instead of it being 2 to the x power, it becomes 2 to the first power minus 3. So we have 2 to the first power minus 3. And what's that equal to? Exactly 2 minus 3, which everybody in here can do for sure. In here. All right, that becomes exactly negative 1. All right. So again, all we did, we took our x value, which in this case was 1, and we plugged it in for x. And so we had 2 to the 1 minus 3. It became 2 minus 3, which gave you an answer of negative 1. Okay, so let's do this again. And we have, in our second example, we have f of x equals 5 times 3 raised to the x power. Now, I could ask you for f of anything. So this time, the examples, let's try f of 4. Okay, so we have f of 4. 4 takes the place of the x this time. So instead of f of x, we have f of 4. It becomes 5 times 3 raised to the, alright, so now before 3 was raised to the power of x, but now since we're replacing x with 4, it becomes 3 raised to the power of 4. And we have 5 times 3 to the 4th power. And what is 3 to the 4th power? Alright, I believe it's 5 times 81. Okay, my 81 looks pretty bad. Let's try that again. 81. 5 times 81. And what does that give you? Work it out on your calculators or work it out in your head. And it 10, hold on, we get 405. Okay, great. Good, great.